I want to do two examples of the sum. Ooh, let's change this to 150. The sum of an arithmetic sequence. We've got this master formula that says S is the number of terms in the sequence times the average of the first and last terms. And there's variations on that, and the book has a few variations on that, but I like this version probably best. And this is really simple. It's a really simple formula. If you know n, a1, and an, and you're done. But what if that's a little tricky? Well, I just want to give you some examples of that. So the first one would be, suppose I have the sum of 3 plus 9 plus 15 plus 21 plus ... up to, let's say, 639. Put a plus there. Yeah, that'll work. So the thing is, they aren't telling you explicitly exactly what all the information is, but the two of the three things are usually pretty easy to figure out. Here we've got a1. They usually just call that a in the book. The first term is equal to 3. That's given. Okay, and a sub n, the last term, is given 639. But they don't actually tell you what n is. How many terms are there in the summation? So to do that, you usually have to just actually kind of figure out the formula for this guy. Okay, so let's go ahead and put it into a formula, and we'll do a little practice with summation notation at the same time anyway. So we want to write down the formula. That's a sub n equals, okay, it's that 3, the first term, plus n minus 1 times the common difference, and the common difference is 6. Now I'll put that, it's a number, so I'll put it in front of the variable. Okay, so that's the general formula for all the terms, and we want to know how would we get 639 out of that. 3 plus 6 times n minus 1. Okay, so 636 over 6 is n minus 1, and that is 106, and so n is 107. So in fact, if we wanted to, you don't have to, but we could write this out as this is the sum from, let's use a funky letter. Let's not be too funky. How about L equals 1? I'm just using that for fun, to show that you can use whatever letter you want in principle. Middle of the alphabet's better, though, to show that it's an integer, suggest that it's an integer. L equals 1 to 107 of this formula, 3 plus 6 times n minus 1. Now, again, we don't have to write it that way. The main thing is that we've got n. Okay? So this n, we need parentheses to make sure that we know that that whole thing is the thing that's being summed up. Because otherwise it would look like the sum of 3 and then just n minus 1. Oh, and you know what? I started talking about L. This is a really easy mistake to make. I copied down a formula that was using the letter n, because n for me means how many terms total did I sum up. And n is really a number, 107. It's not a variable anymore. It's not something that can index and talk about all the terms in here. What I need in here is an L, because that's the dummy variable, the temporary variable, that steps between 1, 2, 3, 4, 5 to create all the terms as I'm summing them up, and then just gets discarded at the end. So I'm glad I caught that. I didn't want to be caught on video being so silly. Okay, so that is now going to be, okay, n, I've got the magic number n, and now I've got the average of the first and last, and that's 107 times 642 over 2, which is 321, and you know what, I'll let the computer do that for me, and so you get equals, well, it disappeared, 34347. Oh, that's kind of a cool number. 34347. And so that is the sum of that sequence. So that's where you have the first and last, but you don't know the number, and you have to actually figure out how many terms are there in there. But what if you had, let's say, 7 plus 10 plus 13 plus 16 plus ... and then they tell you sum up the first 50 terms. Okay, so now, what do I know? I know n is 50. They told me that. I know a1, again, is 7, but I don't know a sub n. Okay, so there's a couple ways to do it. One is that we know d. You can see that the common difference here is 3. And then what we could do, we could use their master formula in the book, which involves just those three quantities, a1, or a, in other words, what they call it, n, and d. But I don't want to have to memorize more formulas than just one, and so why don't we just actually figure out what a sub n is? Okay. Well, a sub n, the master formula is start with the starting term, and then step up by n minus 1 times d. Okay, and I know the n that I'm interested in is 50, and so that's 7 plus 3 times 49, which is 154. And so that's going to be what I put into my formula. So S is just going to be how many terms? Just 50 times the average of the first and last, which I now know is 7 plus 154 all over 2, which is 50 times, that's 161 over 2. That's not very pretty. And so that you could say 25 times 161, but again, I'll cheat a little bit. 4025. Remember, you should get an integer. That doesn't always happen. If these guys are not integers to start with, you're not necessarily going to get an integer. But if you're summing up a bunch of integers, you're going to get an integer. The interesting thing is that this always has an over 2 in the formula. It works out because one of the numbers has to be even, but that's not completely obvious, but it always does work out. And so it's a good check. If you got something with halves in it or something like that, you're probably not getting the right answer for the sum of integers.